Cool. All right, so today we are going to be talking about soil and water. Um, we're going to talk about a lot about soil properties. We're going to do some math, like Lilia said. So if you don't have one handy, now is a good time to get a ruler along with your soil milkshake jar. If you were able to go out and brave the ice and the snow to actually access some soil. If you weren't, no worries. We're going to demo it here today as a group. And then obviously you guys can access the recording of this class later on if you need to do this at another time because you couldn't access soil. And then we're going to talk about water at the very end, which we have a lot of right now. All right, so let's get going. So soil is is kind of the life force behind all of our plants and our growing material. But it's a system, right? It's not just one thing that we see on top of the ground. We have many, many different parts of our soil system. And we want to think about soil as actually being created from way down below. So like from the bedrock, kind of moving up. So soil moves in this very slow cycle, right? From the bottom to the top. And what is underneath, right? In that bedrock and parent material and subsoil, all of that shapes what we're experiencing in that top, foot of soil that we're growing in. So when we're talking about soil, we know that we have the power to control and change some of our soil conditions, particularly in the O and the A layer. However, the further down we go, those are things that we can't access and we can't really change. But it's important to keep those things in mind because some of our really low soil horizons do impact what is happening on the surface. So we're going to kind of move forward with our soil structure talk. We are really going to focus on the O and A layers, which is where most of our annual and perennial vegetables are growing. So these are things that don't have tap roots. If you are growing perennials and particularly trees or larger woody plants, O, A, and E are going to be the three really, really important layers for you going forward. So in all of that soil, in that O and that A layer particularly, it's not just the minerals and those tiny pieces of rock and things that are moving around there. There's also millions of microorganisms. And that's what we want. We want to think about soil as kind of like the digestive system of our earth, really. I love this phrase. It's like, it's the living skin of the earth. So we have geology, right? All the rocks and stuff that are going on way down low. And then we have the biology, all the microbes and the decomposition, and then the humans that are interacting inside the soil. So we want to really think about our soil today, the next class, and then going forward as this like mutualistic relationship. So how we're treating the soil is how the soil is going to treat us, and we're both dependent upon each other. So what that means is that we want to not only cultivate our plants and our own bodies, we also want to cultivate all the microorganisms, so the bacteria and the fungi, the macroinvertebrates, those little tiny insects, and the everything that's living in our soil is super important to building this really healthy ecosystem. So, right, all of these things that are in there, we have earthworms that we see, we have small insects that often lay their eggs or have a dormant period in the soil. We have springtails, bacteria, fungi, and all kind of little single cell organisms that are hanging out and providing really vital services to our soil and our plants. So we hear a lot about earthworms and bacteria and fungi primarily as decomposers. But a lot of those, particularly the smaller single and multicellular things like bacteria and fungi, have really important beneficial relationships with our plants and our plant roots. Lots of bacteria and fungi have mutualistic relationships with roots. So they actually grow on the roots of the plants and then help the plants. They kind of become like a super strong straw or vacuum for the plants that pull up more nutrients or help keep away things that other pathogens that might harm the plants. So healthy soil is alive and well, and we want to make sure that we have all the different pieces of living in our soil to make it a really strong ecosystem. Has anyone ever thought about soil in this way, or thought about all the other things, particularly the really small things that they've seen in soil before?
I encourage the earthworms.
Yeah.
And I fight against insects if I think they don't belong.
Yeah. So insects, right, are a really tricky thing because so many of our insects are actually really helpful. And that's something when we think about an ecosystem, right? We need 90% of the insects that we're seeing in our environment are either beneficial or they have no benefit, but they also don't do any harm either. There's only about 10% of all the insects out there that are considered what we could think of as pest insects. So things that are actively destroying our plants and things. I'm gonna mute for just a second.
Has anybody else thought about our soil in this way? Or is this kind of a new concept? This idea of soil being alive?
I haven't thought about it in detail, so I'm looking forward to what you have to say. I didn't know what a springtail was, but I looked it up.
Oh, cool.
And I recognize some of them now that I've been digging in the earth.
Yeah, great. The internet's such an awesome thing that you can just do that real quick.
For sure. Yeah, and if other folks have it and want to do some fun Googling, the microscopic world is just super fascinating. So there's all kinds of really cool things out there that we can't see, or we only barely see with our eyes. So, and most of them are really beneficial in our soil. And when we create a balance of having a lot of these different things living in our soil, this really happy ecosystem, then we have really happy plants and really happy people. So in addition to all of the really fun organisms that are living in there, right, they are doing a lot of different really cool things for there. So I love this idea of there being chemists for our environment. So they do a couple things. They fix nitrogen. So nitrogen is what, and we're going to talk about this more next week. Nitrogen is what makes our plants leafy and green. And we have lots of bacteria in our soil that specialize in converting atmospheric nitrogen into nitrogen that our plants can take up and utilize as fertilizer. So these are little guys that we're never going to see with the naked eye, but they're really important in making atmospheric nitrogen available through some digestive processes that they do. Plants are all other creatures in our soil, so bacteria, fungi, macroinvertebrates, microinvertebrates, are really important for decomposition, right? We all think about the trusty earthworm as the number one plant decomposer, right? Because earthworms crawl through the soil, they take teeny tiny bites of lots of different dead things, and then they poop out this beautiful soil. You'll probably hear the politer term worm castings, but it's worm feces. And it's a really great, readily available nutrition source for our plants. And so in addition to that, right, as they're creating this nutrition source, they're also making other minerals and trace elements more available for plants to take up. So, and kind of the last one, as we think about different foods that plants need, is phosphorus. So phosphorus helps with our fruit and flower formation of our plants. And a lot of the phosphorus is released Fungi and bacteria help release that when it's bound into other minerals. So phosphorus is most naturally found in like rock and mineral deposits. But we have fungi and bacteria that help break it up and make it into these tiny little particles and other forms that our plants can then kind of pull in through their roots. So everything that's going on in the soil is really working together to create this healthy and interesting environment. So this is why I'm glad you talked about insects and all the other things that are there, but the insects are just a very small portion of all of those different critters that are down low working to make food available for our plants. I also want to shout out to termites and a lot of other decomposers that maybe we don't think about as exciting. Has anyone ever come across those giant black beetles out in the garden? They're kind of scary looking. They've got big pinchers in the front. It's a whole family of ground beetles, and they are amazing decomposers, particularly of woody plants. So if you've ever had a tree down in your yard. So there's a lot of really cool things that insects are doing. And then what they're doing is then being further broken down by the bacteria and the fungi and the springtails in our soil, all of which is making this nice food source for our plants.
So Bethany, we should not kill that big beetle thing.
No, don't kill the beetles.
We should move it over where the trees and the woody plants are in our yard, right?
Yeah, don't kill the insects. They're doing wonderful things for our environment.
So when since if you're planting in the ground versus planting in a container, does that because you're not like, I guess the soil that you're using is just potting soil a lot of the time, and I know you can amend it with compost and stuff, but if it doesn't have like all the same kind of bugs in it, does that make a big difference?
Solid question, right? So then you've got a different ecosystem. So when I really like that framing, Katie, in terms of like our ground, right, is this bigger ecosystem that has all these insects and these beneficial microorganisms that are hanging out in that. Our potting soil and our seed starting soil does not have all of them, right? Particularly the larger critters, because it's been sterilized and it's gone through this whole process. So it's a situation where if you're growing in pots long term, has anyone ever had to change the soil in their potted plants before, or heard about someone else doing that? So that's kind of where, without having those extra inputs and that like kind of system cycling of food, plants in pots will eventually use up all of the food source that is available in them, because they don't have that interaction of animals and rainwater and sunlight and decomposing material that's all being input into something that's growing in the ground. If you're growing in raised beds, it's really a good idea to think about your raised bed as a giant flower pot. That for me has been really helpful to think about why I need to keep adding soil and keep adding compost and doing those other things, because no earthworm is going to naturally crawl up into your raised bed where it might wander into your in-ground garden. So keep thinking about all those ways that you can introduce those beneficials into your soil system through composting. And if you really can't, that's okay, but you're going to have to be prepared to change out your soil in your potted plants in particular, because they will not have those new nutrient inputs that we see as you would in a natural ecosystem. So this awesome diagram, it just shows a little bit about what all of these tiny little critters are doing in our soil. They are kind of creating these teeny tiny highways to help air and water move, be present in our soil, which allows our plant roots to move through. So you can see how we have some nice bacteria in here that is kind of holding the different particles together, but they're holding it together loosely. So kind of like we would use our fingers to hold like a handful of rocks or something. The rocks are in our hands, but we could still definitely move things through it like water. So that's what the bacteria are doing. We also have these great mycorrhizal hyphae, which are just bacteria, right? And they are kind of added onto our plant roots, and they're extending out into the soil substrate, and they connect to each other. And in some cases, they actually can transfer nutrients from plant to plant, or water as well. So it's really cool. This is kind of an example of how plants will work together in an ecosystem and share resources with each other to help benefit everybody. So plants aren't, we talk a lot about plants competing with each other, but if we work to plant our garden in a way that has, you know, plants from different groups, like we were talking about last week, they will actually work together and share resources, because they know if I'm getting enough food and Lilius is getting enough food, then together we'll teach a better class, right? Because we're both happy and prepared. And so plants kind of do this indirectly by capitalizing on bacteria and other smaller critters in the soil to help share resources around. And this is kind of an up close example of what else plants are doing right under the soil, and how these different fungi interact with each other. So in addition to sharing resources, the fungi attached to the roots of our plants also communicate with each other underground. So they'll pass messages from plant to plant through chemical communication, sharing them with what's going on. So for example, plants will view us as predators when we come out and pick, right? Particularly if we harvest a whole lot off of a plant, that makes the plant think, oh my gosh, I'm being attacked, right? And so that it'll send stress signals out to other plants, which will trigger different responses depending on what's happening. A lot of times, right, this can happen because of drought. It can happen when we harvest. If there are pest insects that are chewing on a plant, it will tell the other plants as well. So plants can communicate underground through their fungal network. They also will send out volatile chemicals, right? So plants breathe out air, but they can also exhale other chemical signals that can warn plants about other impending attacks that are going on as well. So just really cool ways that plants are thinking about each other, communicating with each other, and utilizing their friends and neighbors in the soil to pass those messages along. Does anyone have any questions about this or thoughts?
Has anyone seen that mycorrhizae in the soil, the kind of white, if you look at the bottom of the screen, it's there's a good image of it. It's kind of this like white strands that you might see. And I think I cut someone off, sorry about that.
No, I was just saying it makes sense what you're saying. You know, if I've seen that white stuff that you're talking about, I don't know if I knew what it was.
Yeah, so a lot of times you'll almost, when I see it, most of the time, my first response is it's root hairs. And some of it are like the root hair ends, but most of it is actually fungi that are attached to the ends of roots. So it almost looks like a really fine sponge.
I'm going to do a whole lot more looking when I start digging in the garden this year.
Yeah,
awesome.
Yay. There's so much cool stuff in the soil. So when we think about what's going on in our soil, we want to promote a lot of the different bacteria, fungi, micro and macro invertebrates to help build a healthy soil system. So this is just these are all of the things that can help, well, I guess not help necessarily, but can impact all the little different critters living in our soil and impact how well they do their job. So the first is, one of the first things we think about is management. So things like tilling can impact who and what is living in your soil. So crop rotation and planting, what you're planting, and when. Fertilizers, so what you're adding to your soil, how much. Are you adding too much of anything? Or are you just putting it down because this is what I do every year, even though your soil might not need that? Is your soil covered all the time? So covered soil is happy soil, in the sense that you are putting something down to keep the soil from being too hot or too cold or too wet or too dry. So cover cropping or other planting plans come into that. Irrigation and water also play into that, right? Every living thing, no matter how small it is, does need water. Too much is a problem and too little is also a problem. So making sure you're managing water. Rotating crops promotes a diversity of crops, promotes a diversity of soil life. We see this a lot in what we call monocrop situations. So where people plant a lot of the same thing year after year. What happens, right? Nowhere in nature do we have a natural monocrop or like only one thing across a long space. So what that happens is that also promotes single crops of other things like pests, and can also lead to large-scale problems as well, because that ecological balance is out of whack. So some plants, and particularly some of our soil bacteria, do not thrive in those monoculture environments. Other things that will impact our little soil critter friends is our soil texture and our soil type, which we're going to talk about more today. The amount of organic matter, which is that like stuff that's breaking down in our soil, the ability of our soil to drain water or not, soil pH, which is how acidic or basic our soil is. And then all of those things are influenced by our environment, right? So the things that we talked about at the very first class, right? The season, the temperature, the humidity, the wind, the sun, all of those things where we live on the globe all impact what's happening in our soil here. So soils in general, right, are a product of their environment, and also a product of how we treat them. So it's a mutualistic relationship that we want to build and cultivate. We want to build a good friendship with our soil. And Lily has to take it. Yeah, go ahead.
Back to the management on the cover crops. Mm-hmm. Do you think it's necessary to put a cover crop like on raised beds, like if you have a 4x8? Is it better?
So uncovered soil is unhappy soil. Cover cropping is a great way to do a living fertilizer. For some folks, particularly if you're using raised beds, it may not be the best choice for management depending on the specific cover crop. Mulches are other great ways to cover your soil when you're not actively gardening that can provide similar benefits in terms of a safe shelter for our little microbe friends. But cover cropping is kind of like your gold standard, but having a plan to keep your soil covered that still allows sunlight and water to move through is really the place to be.
Okay, so we'll make sure because I haven't been putting anything on mine, so I'll make sure I mulch it from now on. Also, I had a question on the moles. I know they're supposed to loosen up the soil, but they also eat, I think they eat earthworms, and then they eat the, what are the white ones? I forget now.
Grubs, they eat grubs.
Yes, grubs. But if they eat earthworms, I mean, there's pros and cons to them.
Yeah. I still think moles, right, are a part of a whole ecosystem that are there. Earthworms reproduce in very large numbers. One egg sac from an earthworm has about 1,000 1,000 earthworm eggs in it.
Wow.
Yeah, so they're not, I don't think we're going to worry about running out of earthworms in the moles category. And the moles aren't eating your garden crops, but they are pests in other ways in our lawn, and especially in our gardens, particularly when we think about like safety in terms of walking as well.
Sure. Thank you.
Yeah.
Thank you.
Yeah, good question, good thought. Did I hear someone else chiming in?
Okay, so Bethany just laid out some awesome kind of big vision about what soil is and why and how important soil and all of the things that live beneath our feet are to our goals as gardeners. I have a friend that uses this analogy that we need to care for the pets that live beneath our feet, like as gardeners. And I really love that idea that we're out here, not only caring for these plants, but also those little critters that live beneath our feet. So if you have any questions about management and kind of best practices, we'd be happy to talk to you all more about that. I wish we could talk about this stuff for hours, but I'm sure we don't have the time, and we would probably bore most of you. So, Bethany started with explaining the different layers of our soils and how the soils begin from that kind of base layer of the bedrock. And then she talked about the life, the organisms that live beneath us. We're now going to dive into this concept of soil texture and what makes a good soil and kind of an ideal soil texture for growing plants. And soil texture is really this concept of the components of soil. When we think of the mineral makeup, the components of soil, when we think of like air that's actually in our soil, water, and then all of the organic matter that's in there. And that usually, is composed of all of those, all of the things that are alive, the organisms and the other fungi and bacteria and microorganisms that live in our soil. And the things that are being decomposed, by all those critters. So we're gonna dive into this idea that the soil texture comes from the minerals that are in the soil, as well as the ability of water and air to move through it, and the organic matter that's included. So ideally, a good soil has 45% mineral matter, which is we're going to talk about is going to be the sand, silt, and clay that make up the soil. It has the capacity to hold 25% air and 25% water, and then it has this 5% organic matter. Obviously, this is kind of our baseline, and there's going to be different ratios that you'll see in soils. But this is kind of our ideal. And when you have, and what can happen, and we talked a little bit about management, but soils that, I'm sure we've mentioned compaction before, and we might have talked about it when we were talking about, areas where water might sit in your yard. But when soils get compacted, when they're less of a texture of like a chocolate cake and more of a brownie texture, the soil has less air space in there and less opportunity for water to move through. Go ahead and move to the next slide. So the minerals that make up our soil include sand, silt, and clay. And the exercise that we did where we made our soil milkshake is going to help us actually identify those different percentages in the soil that you are growing in. And sand is the largest particle in that mineral makeup. It's something that most of us can see. In kind of an individual particle of sand you could see with your eye. Silt is the next size smaller. Hold on one second. I'm gonna close the door where my husband is on the phone. I'm sure you guys can hear him. Give me 1 second.
Has anyone in the course of doing your soil milkshake or anything else, like felt, particularly right if you're at the beach or felt your soil in your garden to kind of experience this? Right, the beach obviously feels is sandy. It's 100% sand, so it feels that kind of coarse. But these kind of like feeling things, Lilis will talk about more, but you can actually go out, particularly if your soil tends to lean towards one or the other, you can really do a nice hand-based soil texture test too.
Yeah, that's a great point. We can definitely, there's a couple different ways that you can identify kind of the texture of your soil, and feeling it is a great way to do that. Yeah, the sand, I feel like most of us are familiar with the feel of that, kind of that more coarse texture in your hand. Silt is a little more smooth and silky as a texture and how it feels when it's wet, particularly. And if you were to look at like a size of a silt particle, it would be like very difficult. You could see it, but it'd be very difficult to see. Clay, I feel like, is something more folks are familiar with rather than silt. And it's going to be more sticky when you feel it when it's wet. And if you've ever worked with clay, when it's moist, you can kind of form it and move it into different shapes and things. And those particles are so tiny that we can't see them. And so if you have if you're out feeling soil and you, it'd be better if I could show you this, but there's a way to kind of understand your soil texture by kind of running it through your fingers, where the soil will change in form, but we can talk more about that if y'all are interested. Right now, we're going to look at kind of how, kind of visually how it can settle into different layers to figure out the texture. So with those different sizes, there's obviously going to be a different way that water moves through each of those different particles, right? If you were to have a glass full of sand and you poured water through it, the water is going to move through that glass pretty quickly. Those particles are bigger. There's going to be more space between the particles. There's going to be more air between the particles, which will allow that water to move through those channels. If you had a glass that was full of clay, right, and you tried to pour water through it, the water is going to be it's going to look like it's going to be absorbed into that glass, and it's going to not have very much that trickles kind of out of the bottom of it. And then silt is kind of in between. So clay has, in terms of its ability to hold water, it's very high water holding capacity. The water moves through it very slowly. And on the other end of that spectrum, we have sand, which water moves through very quickly and has a much lower water holding capacity. And so ideally, we have a good ratio of these different particles in our sand so that we can, in our soil, sorry, so that we can hold water just enough for our plant roots to be able to access it. and for our microorganisms to access it, but that it won't pool and drown out those things. And so that perfect ratio of kind of the silt, sand, and clay is when we have a loamy soil. If you've ever heard that term before, it's a 40% sand, 40% silt, and 20% clay. And in that loamy soil, there's that ratio allows for the water and the air to move through in a way where water can stick around as long as it's needed, but it's still able to move through the soil and not drown things out. And it also doesn't move so quickly that the roots and the organisms aren't able to get to it before it's gone. So this video that we're going to show you all is actually a way to look at your soil from not just a texture perspective, but also to understand if the soil that you have in your garden is healthy from the way that it's been used and the organisms that live in it. So this kind of takes in all account the texture, because they're going to show you two soils that have actually the exact same texture, but have been managed in different ways. So one's been kind of just continuously tilled and hasn't been allowed to rest or hasn't had cover on it year round, so that microbial community can really thrive. And the other one is kind of the opposite. It hasn't been disturbed very often. The microbial community is very happy and healthy. And you'll see just from this test, like what difference that can make in the soil's ability to really stick around.
Can you hear?
Yeah.
One way of assessing soil health is to examine aggregate stability, or how well a small chunk of soil maintains cohesion when immersed in water. There are two important questions in this context. First, how does this indicate soil health? And second, why is having the constituents of soil, sand, silt, and clay particles, why is their maintaining cohesion important? A healthy soil is perhaps the most diverse ecosystem on the planet, with literally millions of species of bacteria, fungi, nematodes, viruses, and many other organisms interacting with plant roots and plant root exudates. A byproduct of these interactions are soil glues that fungi and bacteria secrete. These glues hold the soil together in clumps called aggregates. A healthy soil will resist falling apart into clay, silt, and sand particles when immersed in water, because these glues, along with fungal mycelia and plant roots, hold the soil together. This picture shows the difference between a healthy and a poorly managed soil. David Granitstein, a sustainable ag specialist at Washington State, dug up 2 corn plants in fields with the same soil type, but which were managed differently. He applied water from a garden hose to both root balls. One field used a lot of chemical fertilizers and pesticides, no cover crops, a lot of heavy machinery, and a poor crop rotation. The other field was not organic, but used manures, cover crops, and tried to minimize tillage and heavy machinery use. David noted that the soil on the root ball on the left immediately washed away, and nearly all the soil was gone after 30 seconds. The soil with the root ball on the right resisted washing away due to the presence of soil glues, which were present due to the farmer providing food in the form of manures and cover crops to the soil ecology. The situation shown here is similar to the corn root ball example. The soil clumps are the same soil type and were taken literally feet from each other from 2 adjacent orchards, which are managed quite differently. The soil on the left is from an orchard where the alleys were kept clean of any vegetation through the use of herbicides, so very little organic matter is returned to the soil, and the soil is starved of organic matter. The soil on the right is taken from an orchard that has cover crops planted every year in the alleys, and has also had animals grazing in the alleys. The soil resists disintegration when exposed to water. As you can see, even though the healthy soil on the right does disintegrate a bit, the water remains clear because the pieces that fall off are microaggregates, so most of the clay particles remain aggregated. So, back to why having stable aggregates are important. First, healthy soils, which are well aggregated, resist wind and water erosion by maintaining their structure. Heavier aggregates are more likely to stay put compared to particles of silt, sand, and clay. If the soil disintegrates, as the soil on the left is doing, the clay particles will rise to the surface and form a seal, after which very little rainfall or irrigation water will penetrate the surface. The roots and ultimately the water table are starved of water. In addition, the clay seal dramatically reduces air exchange into the soil, creating anaerobic conditions that favor plant disease. In summary, soils need to be managed as an ecological system, which means the microbes and other organisms require feeding and reduced disturbance. Regular additions of organic matter, keeping the ground covered with living crops and or mulches, reducing soil disturbance, either chemical pesticides and fertilizers or physical disturbance, meaning tillage, will all support developing and maintaining healthy soils and healthy crops.
Great, thanks for pulling that up, Bethany. So this, what I love about this video is that it's showing where two soils that have the exact same texture can be managed in different ways in order to actually create a better and growing environment and a happier soil. And just kind of to summarize about soil texture, soil texture is something that is really challenging to change. About, you know, in my yard, the texture of the soil that I have is the texture that it's going to be in terms of, you know, that percentage of sand, silt, and clay that exists. What I can do in order to improve it is to incorporate organic matter into the soil and to manage it in a way that allows that organic matter to stick around and that microbial world to be fed, so that the soil is actually can look very different through management than one that might be the exact same texture but doesn't have that that healthy microbial life and the cover and the organic matter in it. I'd love to hear y'all's kind of reactions to that video and to these ideas, because it might be something that is new to you or something that you've seen before. Does anybody have any thoughts or reactions to kind of even just that experiment, or any questions about what was happening there in those two pitchers of water as that soil was being absorbed?
I was thinking about, so if you pulled, say you were pulling plants out of your garden for whatever reason, if you pulled one of your plants and it came up with a root ball attached to it fairly well, does that mean that your soil is pretty good or not necessarily? I was thinking about that when that clump was staying together on that one plant.
That's a really interesting question. If your soil is really healthy, it's more of the texture of like a chocolate cake. So it's got, you know, it's not going to be dried out. It's not going to be compacted. It's going to have really good space in there for air and water to move through. And so in my mind, I would think that if you were able to, you know, to pull a plant out by its roots in a way that, you know, the plant itself isn't going to rip off, that could be a sign of a healthy soil, because it is kind of that light texture that you have. It could also be a sign of a different soil texture, though, that is not healthy. Like if you had a very sandy soil that doesn't have a lot of organic material in it, that's creating those aggregates that guy was talking about, those glues that are holding soil together. You actually, in a sandy soil, could pull something out pretty easily. And that might not be a sign that it's a healthy soil. So it depends on some different factors. I don't think it would be a clear indication.
But it would still be a good idea to kind of check to see how your soil looks if you pull a plant out, how your soil actually looks and kind of feels in that, to look for different things.
Absolutely. And I'm hoping that as we're talking about this is going to help you all get some tools to actually be able to go out and look at soil and kind of, see, feel, touch it, and see if you can start to identify, what is healthy and what is not. Kind of think about those identifiers. Because it's not necessarily like the color of the soil in particular. Like I've been in Oklahoma where their soils are red. And so the color of the soil is not necessarily an indicator of whether it's a healthy soil or not. In terms, like I feel like we go toward, like you might see a soil that is a certain color and think, oh, it's clayey soil. And so there's other factors beyond just the color.
So I've got one of my beds is a raised bed where I have started with the bags of soil, and I add to it each year. The other bed, I just started using, it was actually a daylily bed that I converted into use for my vegetables. So that bed is going to be totally different as far as the soil than what my raised bed is. So I'm going to compare the two when I start to plant and just see if I can tell what type of difference. I should be able to tell there'd be a good size difference in the two.
And I think the soil texture test, the soil milkshake test, this might be a good segue into talking about it, because this is a really, really pretty easy way to figure out your soil texture and those ratios that Lilis was talking about, rather than relying on something that can be so dependent on other, like even how much water you have in the soil the day that you pull up those plants can impact what the soil looks like on that day.
Yeah, absolutely.
So maybe we should talk a little bit about our soil milkshake.
Yeah, and Nancy, you could even do this in both of those beds, and compare them to see what the difference is.
I'm going to do that. I'm going to do that.
Yeah. Okay, so I went ahead and created a soil composition test from soil that's in my garden. And Bethany is going to put a picture of this up in a second, so you can actually see the layers a little bit better. But this is when I said to make sure you shake this for 2 minutes. It's because you really are trying to break apart all of any sort of, glues or any, like aggregates in the soil, to be able to sort it out into the layers. It's not going to happen 100%, but this will show you, good enough how those layers are settling out to be able to identify your soil texture and see the sand, silt, and clay layers. So why don't you go ahead and put that picture up, Bethany, and then I can talk you all through what my jar looks like. So this is a close-up, and I'm going to, let's see. Oh, I probably can't. Well, maybe I can.
I was going to say, if you want to talk, I can write on this while you're going.
Okay,
that way you're not multitasking as much.
Cool. So if you look at this on the very bottom, you'll see the sand layer, and that's going to be the layer where you can really kind of see the particles, like, you know, from each other. You can see that there's kind of some air between some spaces down there, but that's kind of your chunky layer, right? That you're going to be able to see that settles at the bottom. And then the second layer is the silt. It's this medium brown, a little bit lighter than the color of that bottom sand layer. So that's our silt layer there. You can't really see the particles from each other. And then the very, very thin, very light brown layer that's at the top and kind of below the chunky stuff is the clay layer. So this might surprise some folks that that's a pretty thin layer, but that is where the clay is settled. And there's still some clay in the, probably in the water that's still settling. The water is not perfectly clear, so there might be a little bit still in there. But that is, if you've done this, that's what you're looking for. You're looking for those three layers to settle out. The stuff that's floating at the bottom, at the top, and that's the chunky stuff kind of on the top is the organic material that's in the soil that you can see. And so I went ahead and marked my 3 layers with some black marker there on the left, so that I could calculate my percentage of each and be able to figure out what my soil texture is. So the first step in doing these calculations is to measure from the bottom of the jar to the top of that clay layer, and that's going to be your total height of soil. So if you all have, I should pause there for a second, and if you have the handout that's called Calculate Your Soil Texture, and it has an image of a triangle on the front with a bunch of different you know, words like clay, clay loam, things like that. And then there's a second page that's Calculate Your Soil Texture. We're actually gonna write these values in. If you have that in front of you and you wanna use my values to calculate, feel free to do that. Or you can hold on to this and do this, you know, if you've got one, your own jar, or if you're gonna do this at a later time. So I'm gonna start by calculating my total height. And I like to use millimeters because specifically because that clay layer is very small. And so it allows me to be able to, you know, not just think, okay, maybe it's like 1/10 of an inch or something, but millimeters just kind of helps being able to use a number that's more accurate. So my total height was 67 millimeters when I measured this. So I'm gonna go ahead and write that on my sheet, 67 millimeters for total height. And then I'm gonna measure each individual layer. So let's start with the sand. We'll measure from the bottom of the jar to where that first black mark is. And my sand layer is 42 millimeters. Then we move to the silt layer. So I'm gonna start at the first black mark and I'm gonna go to the second black mark and measure my silt layer. And that was 23 millimeters. And then I don't know if you can tell the difference between those 2 tiny black marks at the top, but my clay layer is the space between the second and the third black line, and that was just 2 millimeters, so very small. I'm gonna pause there and I'm gonna let y'all ask any questions you might have on the figuring out the layers or, you know, any of the measurements that we've done up to now.
So how would you rate your soil as far as going by this? Because you really don't have much clay there, do you?
Well, it's a great question, and we're going to get to that.
Oh, okay.
As we do these calculations. Yep.
Okay.
Okay. Well, if anybody else have any questions at this point? Bethany, are you able to pull up the worksheet? If not, we can continue in this image. Oh, cool. Okay, so we're going to move over to the second page of the worksheet and do some more calculations so we can actually determine, now that we have the measurements of each layer, we're going to convert that into a percentage because we want to know what percent of, it's 67 for the total height, Bethany. What percentage each layer makes up of our total soil height. So 23 was silt and 2 is clay.
Yeah.
And I would just say, you know, these are, when you're doing the measurements, you might see that it's hard, it's difficult to know exactly. You just want to make sure that when you go back and double check the height of each layer, that all those 3 add up to your total height. So 42, 23 plus 2 is 67 there. And that'll help you get to the percentages that are useful. So now let's calculate our percentages. So we take the height of our sand layer, we're moving down to 3A, and that was 42. And we're going to divide that by the total height of 67, and then multiply that by 100. And so when I did that calculation, I got that it was 63% is my sand percentage. And then we move to the second one. Oh, cool. Yeah, go ahead and put that on the front page. That's helpful. Then we move to the second one. We're going to do silt. So silt was 23, and we're going to divide that by 67. And that's going to give us 34%. And then for the clay layer, we've got 2 divided by 67 in that total height. And that's going to give us 3%. And then again, you just want to check and make sure that these add up to 100. When I did these, I rounded a couple and just kind of, made sure that I could get to these numbers that break down into 100. So you might have to just go back and fiddle with it a little bit. Then we're going to take these and we're going to go to our soil pyramid, soil texture pyramid, which is the front page of your handout. And we're going to identify what type of texture we have. You see that loam kind of in the middle bottom as being the ideal. Just kind of remember that as like our ideal soil. And as we come out from the loam area, we'll see what our texture is, and that will kind of help us understand how to work with our soil. So our sand percentage is 63. Our silt percentage is 34. And our clay percentage is 3. So now you want to go to, and maybe Bethany, will you switch over to the, oh, I didn't put the arrows on here. Okay, so I'll help you with this so you can figure out how to use this. So if we first look at the sand across the bottom, that's going to be where our sand percentage is. And we're going to go over to 63, which is going to be, a little bit towards the middle between 60 and 70. And we're actually going to go to the up and to the left is the line that we're following for sand, if that makes sense. Do you see those white lines? So yeah, that angle, that's our sand. And I will show, after I talk through this, I'll actually show my, the way I drew my lines on here, because I think it's hard to draw lines on the tool that you're using, Bethany.
It is.
So
I'll do my very best.
Yeah, I'll show that afterwards so that folks can see where, you know, where we end up. So then when we go over to silt, oh, you're gonna do it.
This will help allay anyone's fears of doing things perfectly.
Yeah, you're braver than I am.
Yeah, we'll see how this goes. All right, here we go. Following the line. So no fears, anyone of.
So does that make sense to y'all that she drew that line just to the left of the 60 at the bottom because we're at 63%? And then went up and to the left on that diagonal. So then when we move over to silt, which is on the left or on the right side of the triangle, we're gonna go to 34%, which is gonna be, you know, about halfway between 30 and 40. And we're gonna follow the arrow down, the line that goes down. Yep, exactly.
All right, here we go.
So we wanna draw a line. Yeah, about 34 all the way across the triangle. Beautiful. And then we're going to do our last percentage, which is clay, right? And we had that 3%. So we go to the left side and just a little bit off the bottom, we're going to draw a line straight across from the left to the right.
You didn't warn me that these were going to be so tiny. Oh, man.
Oh, you're doing a great job. This is so awesome.
All right.
Okay, perfect. So then if y'all notice where those three lines intersected, we drew our own little baby triangle. And that is, that where that little triangle is if you want to color it in, or I don't know.
Let's see what I can do here.
I can also show my, oh yeah, perfect. So that little triangle is what our soil texture is. And where it falls on this pyramid is what our soil texture is. So it's falling in the sandy loam, and it's pretty like much in there. If it was like closer to the loam, then I would think, okay, it's sandy loam, but it's closer to loam. Or if it was to the right and it was closer to the silt loam, and say, okay, it's sandy loam, but it's got some silt. So this helps me understand that my soil is loamy, which is a good thing. It's got a good percentage of sand, silt, and clay, but it tends more to be sandy. And if I'm thinking about how, why that's important, I would think, okay, so my soil has, is more sandy than silt or clay, which means if you think back to what we were talking about in terms of water holding capacity, what would this soil tend to do if it's a little bit more sandy? How would water move through the soil?
It would drain well.
It's going to drain well. Yep. Is it going to, is the water going to move faster through the soil than I would like, or is it going to move slower through the soil than I would like?
Faster.
Yeah. And then if we think about if water's moving a little bit faster through the soil than I like, what conclusions could we draw about the organic matter in the soil, or maybe a fertilizer that we might add to the soil, or is it going to stick around for a while, or is it going to, you know, go away?
Go away, wouldn't it? It would wash through.
Yeah.
Yeah, so it will tend to, the organic material in this soil is going to, is going to move a little bit faster through the soil than I would like. And it's not going to move really fast. It's still loamy, which is a good thing. But these are just things to think about, you know, as you understand your soil texture.
And you would have to water more frequently too, right?
Yeah, you might have to water more frequently. Yep, you're going to want to go out and look at your soil more often than you might think, right? So what if we flipped this and this was a clay loam soil rather than a sandy loam? What could we say about its water holding capacity?
It would hold water.
Yeah, would it hold water? Would the water move through faster than you would like or slower?
Slower.
Right. So if you
would having the either loamy, sandy loam or clay loam impact the roots going through as well?
Their ability to move through the soil?
Uh-huh.
Yes. So you might see, what would you think?
Well, I was thinking that, you know, you might want some of the sandy loam to be there so the roots can get through the soil and spread out. And then it'll also depend on the kind of root system the plant has as well, because some of the roots are not deep roots. You know, we talked before about it being deep roots, and some of the ones spread out. So it depends on what that soil looks like during that time, if it would support the plant itself too.
Yeah, absolutely. Do you think a carrot would grow, just as a general idea, better in a sandy loam soil or a clay loam soil?
Sandy.
And that's not saying that you can't grow carrots in a clay loam, because both of these are still loamy soils, right? They're still
right.
A pretty good texture, and can support and have a pretty good ratio of those different particles. But you might see that in a clay loam soil, if you wanted to grow carrots, you might need to add, you know, incorporate a higher level of organic material into that soil than you would if you had a sandy loam, just in order to have that space for the air and water to move through and those roots to move.
So that also means that the soil you might want different kinds or different things in different parts of the garden depending upon what you're planting there.
Like if you had different soil textures?
Yes.
Yeah, exactly.
But then that also means that you might need to rotate it the next year depending upon what you need to put where it is. So it's important to take some time to look at the soil before we start putting the plants in.
That's what I'm hoping.
You got it. You just nailed it. Thank you for summarizing it so well.
I was just thinking about my bed, my raised beds, and different part. I always try to shift and move the tomatoes in a different place in different parts. But I was thinking that as I listen to this and look at that experiment and all that stuff, it makes me think I've got to spend a lot more time on the soil before I actually get in there with the plants. So next month will be a time to get in there with the soil.
I like the idea that you just said. I love that you just said you want to spend more time with your soil.
Mm-hmm. Well, I never thought about it. You know, I just put it in there, and I'll change I'll add fertilizer, especially with the raised beds. I know that you know, my raised beds touch the ground. So I know that, I mean, the dirt that I put in there actually touched the regular ground, but I know I need to get in there and move it around. And so sometimes I didn't have the knowledge that you're giving us now to know that I needed to put to add things and take away things and add more compost or add more sand or whatever I needed to do. But this is helping me think about, so what do I want to do, when and where?
Yeah, absolutely. I will say so this soil, this sandy loam soil, is the soil that is on the ground, that is in the garden bed where I grow directly in the ground. And I have raised beds that where the soil was a mix that I had, you know, purchased from a landscaping company. It was delivered, and that soil is a silt loam soil. I've done this test on that one, and the you know, I have to manage those soils in two different ways, right? I have to go out and check the bed that's in the ground. It definitely needs to be watered more often. And actually, I've learned with the silt loam soil that that there are some crops that don't do as well in it because it holds water more, right? And so, and I'm working to improve it with more, you know, organic matter, and I'm going to do a cover crop on it this spring. And I've got, you know, I've got it covered from the winter. It's been mulched, but it just helps you. It's like another tool that helps to maybe identify some issues that you might have had for those of you that have gardens that have been growing. This might help. I'm hoping this is going to help you, you know, maybe identify some of the challenges or the issues that you've had and be able to think through those a little bit. Does anybody else have anything that this has kind of a light bulb or anything that's kind of turned on in your mind about maybe a current garden you have and how this might change the way you manage it or affect kind of how you think about your plants?
For me, definitely.
Does anybody have a soil composition test that they did that they've been going through this calculation with us right now on? That wants to share what their texture might be? And if not, no worries.
I did mine, but I don't think it's been sitting long enough because I just did it this morning.
Oh, okay.
So it's starting to separate out and it actually looks a lot like yours, but like with the silt and the sand amounts are starting to look a lot like about what, but it's still settling. So I think I'll do my measurements tomorrow.
Okay, cool. Well, if you want to share, you know, next week what you end up with,
okay.
I think I'd at least be interested. I'm always interested to hear what other folks have.
Me too.
And this is from a raised bed. So.
Oh, cool. Okay. All right. Well, any other questions or comments about soil texture before we move into talking about water? Bethany, you did such a good job drawing those lines. I could not have done that.
Oh, thank you. That was very stressful.
I have a question.
Yeah.
When we bought this house, a lot of the beds or the flower beds were mulched with rocks. And so I wanted to plant, well, you know, you can't plant in rocks. So I had to remove wheelbarrow after wheelbarrow of rocks and replace it with soil. But all that soil was so dry and it just didn't look like it had any life at all in it that was around those rocks. because these rocks were deep. They were like 8 or 10 inches deep.
Mm.
So I guess my question is, does the heat from, like, if you use rocks to mulch with, does that it dries out the ground so much that it really does kill off everything, and that's why the ground looks like that?
Yeah, so they're rocks, right? Just like our pavement outside is a really great heat sink. So they create that nice thermal mass. And over time, right, a bunch of warm rocks against soil can heat up your soil and dry it out, which and in addition, right, to just the heating and warming properties, which can move some of our great small friends out of the way. The rocks also physically compact soil, which again, right, no matter how small those little microorganisms are, they still need air and light and like a comfortable environment to live in. So those rocks just basically created a hostile environment for a lot of the microbes and a lot of the macroinvertebrates too. And so they moved out. It doesn't mean you can't revive the soil, right? So doing a lot of things, we've talked a lot about organic matter, and we're going to talk so much about it next week. And right, so the organic matter, things that are decomposing, or things that are alive and recently dead, is kind of how I like to think about it, are ways of bringing a lot of those bacteria back in, as well as creating that fluff in your soil through providing space for water and air to move through as well. So you can totally revive it. It's going to take time because you've got kind of a very harsh environment going on right now.
Thank you. Also, that brings up another question. I have a lot of houseplants, and I have been putting rocks, the decorative little stones and the little tiny colored, well, not colored sands, but sand down on top to make a layer to try to help with the fungus gnats, to keep those from burrowing down in there and laying eggs. Does that have the same, does rocks or sand have this, I mean, you know, it won't be hot like it would be outdoors. But
well, not in the same way. When you've got a more controlled environment, or you have more ability to control your environment, I guess is probably a better way to think about it with a house plant, right? So you're controlling how warm it is, if it's sitting in the sun, if it's not sitting in the sun, you're probably watering them on some kind of schedule. So you're moderating its environment a lot more than, say, landscaping with gravel. Whereas you kind of put it down, and your hope is that, you know, the sun and everything else is going to basically create this hostile environment that only grows more rocks. So I wouldn't worry about it as much, because you're controlling that environment more.
Thank you.
And I would also say, in those scenarios, you know, listen or look at the plants and the soil, and just take cues from what's happening with them, because they'll tell you, you know, if it's not working out. If you're, you know, you were saying that soil underneath those rocks was just dry and in a bad place. And so I would assume the soil underneath your house plants is probably absorbing water and is doing much better if the plants are thriving. And
right, okay. Thank you.
Yeah. Any other questions? Okay, should we talk about water?
Let's do it. So we've talked a whole lot about soil, right? Which our soil is the environment that creates food for our plants. Because plants, as we know, can't get up and go get their own food. They've got to wait for it to come to them. And they utilize their whole underground network to bring food to them. And that also goes for water. So water is the other thing that all living things need to grow. Plants are 80 to 90% water. And I think that's super important to think about, because once we get above that percentage, like too much water can be a problem, and very much so too little water can be a problem. So plants, if you've ever seen plants that look kind of sad or droopy, that's because they don't have the water that actually physically helps, like pumps out their cells and helps them be supported and structured. So water, right, is a key ingredient in photosynthesis, which, as we talked about, is the process by which plants make food for themselves. Water is also absorbed and then given off through the pores in our plant leaves. So if you've ever been under a tree, right, so it provides physical shade from us from the sun, but you'll also notice that the air under a tree is more moist feeling frequently than the air around it, especially on a hot summer day. And that's because the tree is actually sweating. We can kind of think of it that way a little bit as it exhales. Water is also how plants move nutrients through the soil. So potassiums and a lot of our salts are water soluble. So having sufficient water in the plants helps move the soil nutrients up all the way to the very top of their plant. Water is the key to life, right? It cools things, it helps things germinate, it helps things grow, it helps plants stay upright. So there's got to be some really fancy scientific formula for how much water plants need to grow. And the answer is, it depends. Right? It depends on your soil texture, right? Like we just talked about. You know, if you've got a sandy soil, your plants are probably going to need more water than if you have a silty soil or a loamy soil, because water moves through more quickly through different soil textures. It also depends on how hot it is and how humid it is. And we experience this ourselves, right? In the summer, when it's hot, we sweat more and we lose more water and we feel more thirsty. In the winter, we don't sweat as much, we don't lose as much water, we don't feel as thirsty. And plants kind of experience the environment in the same way, right? So they transpire, so they lose heat through their leaves as well as through evaporation from the soil and then also from their plant body during the day. So plants also experience just daily water loss, just like humans. The other factors that help us think about how much water a plant needs is your plant's age, size, and type. So more mature plants need more water because they have larger physical structures that need, right? 80% of a large plant would be more water than 80% of a small plant. So the older, the more mature the plant, the more water it needs. Seedlings also require a lot of water, but they need lots of water a little bit at a time. And that's mostly because they are living in, normally if you've got seeds inside, we talked about those very shallow seed trays. So they want their soil to stay nice and moist, but we can't supply a whole lot of water for them all at once or they'll drown. So they need a lot of water, but very consistently. The other thing, right, in terms of our plant age and size is the structure of the plant. So we looked at last week about how the root depth of the plant impacts its spacing. And the root depth of the plant also impacts the water needs. So if you have well-watered soil and a plant with really deep roots, that plant has more opportunities to gather water through more area in the soil. If you have a plant with very shallow roots, it can only access the water at the depth of the root. So you may need more water, it may need more frequent watering because it's got such a small area in which those roots can soak up water. So how do we figure this out? Lilius, do you want to talk about that?
Yeah. So we'll talk about kind of how to think about water and in an outside, when our plants are outside. And the general idea is, you know, that our plants need about 1 inch of water per week, really in like a very temperate climate. So if it was 65 degrees outside and the wind wasn't blowing very strong, and you know, it was cooling down a little bit at night, then about an inch of water per week and our plants would be happy. But that's not every day, and it's definitely not every day here in Kentucky, right? So we have to really pay attention to the weather, and also what is happening with our plants and the soil, to really understand how much water those plants need. When it's warmer outside, they're going to need more water, right? When it's and we'll go through kind of some other things that that will show us whether or not our plants need more water or not. But as the temperatures cool, they're going to need less water, and you really just need to pay attention and read the cues from your soil and from the plants and from the weather. As a general guideline, in raised beds, they're going to dry out faster than if you were growing right in the ground. And so as a general, you'll want to check those more often to see if you need to be watering more often. And kind of as a general rule, the best time to water is going to be, especially in our climate, is going to be in the morning or in the late afternoon, when it is, especially when it's really hot outside. Because, you know, a lot of times when you see folks who have their sprinklers on right in the middle of the day, most of that water is actually just evaporating and is not reaching our plants. And also there are plants that want to not sit with water on their leaves. And so if you can water in the morning, then the plant has the opportunity to dry out a little bit and not sit in that water. So early morning is a really good time to water, and late afternoon is another option. You see this picture of a little a rain gauge here that's collecting some water in a garden of lettuce. And these are great to have in your garden to be able to see how much rain, how much irrigation, or how much rain the crops are getting on a weekly basis. I have one that sits out in my garden, and I can check to see. That's kind of my first cue, is like I can go out and see, okay, how much has it rained this week? And that's kind of the first clue to know if my plants need more water. And then I can look at some other clues, which we'll get into. So weather can dramatically affect the water that's available to our plants, and whether or not they are able to get access to it, and if the soil has absorbed it. I talked a little bit about the temperature in terms of, you know, if it's hotter outside, we're going to water more. If it's cooler, we're going to water a little bit less. That has to do obviously with evaporation, the water evaporating off of the surface of the soil, and that transpiration that's happening within our plants. The hotter it is, the more the plants are transpiring. And so we'll have to just, you know, be able to give them more water when it's hotter outside. Humidity can affect. So in general, during the summers here in Kentucky, the air is very humid, but in the winter it's pretty dry. And so if you are gardening through the winter, we talked about this a little bit during our seasonality conversation about how plants manage the cold and how they survive in the cold. And one of the things that can actually damage a plant faster in the cold is when the plant is really dried out. So even though it's cooler in the winter, we still want to make sure that, and might not need as much water as often, we still want to make sure that our plants aren't totally drying out. So we want to be checking them. And the wind can really affect the dryness of the plant as well. Wind can actually, you know, the plants can dry out faster on a windy day. So if we have a lot of wind in the middle of the summer, you might think, oh, I need to go check the plants after that to make sure that they haven't, you know, dried out and I need to add some water. And then obviously if it's raining a lot, then we know that the plants are, they're getting a lot of water at that time. So those are just different things to think about in different weather situations.
And I also want to point out with the weather too, right? We talked about keeping your soil covered, and that is a really great tool for slowing down the rate of evaporation, whether that's in the summer, right? As we're getting these really like that beating hot sun, physically covering your soil will slow down the rate of soil evaporative loss, as well as in the winter, right? Holding onto water. So once it's time to water your plants, you really want to focus on getting the water to the roots of the plants. We talked about how the leaves, right, expel a lot of water through transpiration. The leaves do not absorb any water. Therefore, we really need to focus on watering at the base of the plants, focusing on the roots. The roots are kind of like the straws of the plants in terms of sucking up water. Lily has mentioned this some before, but we really want to reiterate that there are lots of plants that do not like having wet leaves. A lot of those include our summer favorites like tomatoes, squash, and melons. Those plants, if they've got wet leaves, particularly because they tend to have leaves that clump together, that moisture plus the heat and humidity becomes a happy environment for a lot of plant diseases. So really water the roots. Can't stress that enough.
And so we wanted to give you all a little bit of information on how you can read the signs from your plants to understand if they're getting enough water or not enough. The first thing I'll say, which I don't know that I've actually said this yet, is the best way to go out and know if your plants, or one of the best ways to go out and know if your plants are getting enough water is to actually go and look at the soil. So I know that we're all looking for, but most people would like to know that they can turn their, you know, water on or go out and water a certain day every week, and that will be, you know, that will be sufficient. And what I would say is, you know, have that plan, and in between, go out and look at your plants and go out and look at the soil. Go out and actually stick your hand in the soil or get your trowel out and dig out some soil to see if that soil is moist. See how far down it's dried out. And that will help you understand if you need to be watering more or less. And then look at your plants. So there are some plants that are just naturally wilt with the heat of the summer. Tomato plants come to mind when I think of a plant that in the middle of the afternoon on a 95-degree day is just going to look a little wilty. And so that is a normal thing that happens. But if the plant is, you know, wilting all throughout the day, you know, you see it in the morning and it's wilty in the afternoon, in the evening, that could be a sign that it needs to have some more water. Like Bethany said, the water is not just needed to move nutrients, but it's for the structure of the plant. It's actually holding the, you know, those stems up and needs it to do that. Another sign that your plants might have too much or too little water can be stunted growth. If water, you know, the plants need that water to move those nutrients through, those water soluble nutrients through, and to complete the photosynthesis process. And so that's going to be a key sign that there might be a water issue. It can be a sign of other things, but you can go out and say, oh, you know, my plants haven't grown very much. I wonder if they're not getting enough water. I wonder if I'm watering them too much. And you can go out and look at the soil and find out. Leaf edges turning brown is a sign that, and I always switch this in my mind, that they're getting too much water, Bethany? Yeah, yep. That they're getting too much water.
They'll turn yellow first and then brown. So yeah. brown is too far. Yellow, yeah. Yellow is.
And then this kind of idea of like cracked dirt around the base of the plant. I feel like we've all seen these images of like dried out soil can be a sign that the soil is not moist enough, and so those are some signs. Are there any other signs that we don't have on this list that we should share with folks? Or that other people have, you know, seen in their gardens that you wanted to share? Okay, well, feel free to share them if you think of them.
So for the last couple minutes, we just want to talk about like ways to get water to your plants. And really, right, the key is actually getting water to your plants. So this is always use the method that you have and try to get the roots, get water to the roots first and foremost. You can do that by using a hose with a wand, right? So that you can physically point the water down to your plants. You could also write a watering can, could provide the same way. Sprinklers, another great way to water. Sprinklers tend to be more overhead generally. It's hard to find, and there very rarely exist like sprinklers that are getting kind of that 6 inches and lower in terms of watering. Soaker hoses are wonderful. So this is, think of it as a garden hose that has lots of teeny, tiny holes poked around it, but on all sides. So it's almost like you've got a sponge attached to a garden hose, or a garden hose that kind of looks like a sponge that emits water throughout the entire hose. And then the other really good option there is drip irrigation. So this is a piece of, it kind of looks like tape that you attach to a hose or a hookup, and it's got little pinpricks in it every 6 to 12 inches, depending on the specific irrigation method. And that just lets water trickle out a little bit at a time. It literally drips out, hence the name. And so these are all different ways to get water to you. We're going to talk a little bit about them as we go, or maybe do we want to pause and kind of wrap up for today and then hang out for a few? What do you think?
I think let's pause and wrap up. And if folks want any more information on any of those watering methods, we can share. There are some links in this presentation to some videos that I made on drip irrigation, setting that up at your home. You know, feel free to check those out or ask questions, but I think now's a good point to wrap up.
Yeah, absolutely. So go ahead.
Well, so we've talked a lot about soil today, and soil texture in particular, and also about just the world of life that lives beneath our feet and how important you know, they are to the success of our gardens. And then we also talked about water and watering needs of plants. And so as we wrap up class, if you all have any questions about the content that we covered today, please stick around if you want to stick around for a little bit and we can chat, or feel free to call or email us over the next week with any questions. Next week, we will discuss those soil samples that you all submitted. If you did, hopefully you have received or will receive your soil lab results in the mail by next week's class. If you don't, we will have a sample test result to talk through with you all that we can look at as a group. And then, you know, once you receive yours, we're happy to talk through that with you. And then we'll also talk about composting and, you know, amending your soil with all types of things in order to, you know, improve the nutrient content in the soil. I don't think we have any homework for you except to, if you haven't been able to, to do that soil texture test. I think the snow is going to melt this week. It's already working its way out. So it would be a good time to do that if you haven't been able to. We'd love to hear from you all what soil texture you have, and if you have any questions about how to work with that texture in your garden. And if you have any plans that you'd like to share as you're working through and scheduling out your garden plans for this year, based on the things that we've just covered in class, please send them to us, and we're happy to put those up on the screen next week, or even just if you want to just share something about your experience as you're working through your garden plan next Monday. Feel free to do that as well. Anything else?
I think that's it. Yeah, send us some garden plans and let us know how soil sample results. I will get folks soil samples. We're going to create a file in Google Drive, and I'll send that out on Friday with everyone's soil samples, so you all can access those through there. So that'll come on Friday.
So they're not getting them in the mail?
I think if you have an email address on there, you've got it in the mail, or it's coming, but I've also got a copy that I'm getting. So I will have all of those. That way we know for sure folks got them. So we'll upload those on Friday for everyone.
That's great.
Yeah. Yeah. And we will hang out for a little bit if folks want to talk more about anything with soil.
Thank you so much.